Alright, this is from assignment 3.5. This is problem number 8. It's very much a physics problem, so if you have never taken a physics course, this problem is going to seem kind of daunting. It's not as bad as it looks. So what we have is we have an equation S of t, and S represents displacement. And displacement is how much something moves. You know, how much did it displace? Did it displace 100 feet? Did it displace 20 feet? Did you maybe go 100 feet that way and 50 feet back? Well, that would be a displacement of 50 feet because you're 50 feet from where you started. So that's what displacement is. Um, the idea, so this question is giving us this equation, S of t is equal to 1 minus 3 cosine t. And it asks us to find velocity to start out with. So one thing to know is if we have a displacement function, the derivative of that displacement with respect to time is equal to velocity. And so that's equal to v. And so what we'll do here is we'll take ds dt. Using linearity, the 1 will go to 0 because the derivative of any constant is a 0. The derivative of negative 3 cosine t is sine 3 sine of t, and the reason why that is because remember we could pull out the 3 because it's a constant, and due to linearity we can pull out the 3 and not change that at all. Then the derivative of cosine of t, well, more correctly, the derivative of negative cosine of t is sine of t. So we're just left with 3 sine of t, and we're evaluating this at a certain time, at time pi sixth of a second. And that's important. We need a specific time because this is, in fact, the velocity function that works for any point in time. So if we want to figure out what the velocity is at one point in time, we need to have that point in time. So we'll plug in pi sixth. Pi sixth of sine of pi sixth is 0.5. And so what we end up with here is 3, which is this constant out here, times 0.5, or 1/2, whatever you want to call it. And that's going to equal 3/2, or 1.5. So one of those two. Let's go with 3/2. We'll stick with fractions. So sine of pi sixth is 1/2, and so we multiply by 3, and therefore the velocity is 3/2, and I believe that's in meters per second. And this kind of makes sense, right? Because unit-wise, this function s of displacement was just in meters. But when we take the change in position with respect to time, we now have meters per second, which more common here in the US would be miles per hour. That's displacement per unit time. The next question is, what is the speed? Well, speed and velocity are funny terms. They mean a very similar thing. So velocity depends on direction. In physics, we would put an arrow over v to represent that it's a vector. In other words, it's not just some scalar value, like 1. It's some scalar value with a direction, like 1 to the east, or 1 to up, So velocity is a vector, it points. Speed is the scalar value of that vector. And so you could say that it's actually the absolute value of velocity. So the absolute value, or the magnitude, we call it in physics, of the velocity is equal to speed. And in this case, the absolute value of the velocity, which is just 3/2, the absolute value of that is simply 3/2. So as well as the velocity being 3/2, the speed is also 3/2. Now if this velocity would have been negative 3/2, we would just take the absolute value of negative 3/2 and the speed would still be 3/2. Alright, so the speed is 3/2 as well. We'll just circle this twice. The next question is, what is the acceleration at that point? Well, acceleration is how fast your velocity is changing. And so it could be represented by the derivative of velocity with respect to time, which is also the double derivative of displacement, or d2s dt squared. That's the second derivative of our displacement function. And so we'll just take the derivative of velocity, and this is going to give us a, or acceleration. So d2s dt squared is going to be the derivative of velocity. The derivative of 3 sine of t is the constant stays out. 3, the derivative of sine of t is cosine of t. So we have 3 cosine of t, and we're evaluating it at the time t equals pi sixth. Now pi sixth of cosine is root 3 over 2, I believe. So now we have the constant 3 times root 3 over 2. And now the units are in meters per second squared, which can be kind of confusing in and of itself, but I want you to think about it this way. Velocity is how much, acceleration is how much your velocity is changing with respect to time. So just like with displacement and velocity, velocity was how much your displacement is changing in time. So in other words, 5 miles an hour. But when you're on the highway and you're getting on the on-ramp and you're going from, like, say, 25 miles an hour up to 80 miles an hour, there's some acceleration, right? Because your velocity is changing between points in time. And so if velocity is meters per second, acceleration is how many meters per second you are getting or losing per second. So it's meters per second. And so now that we have this, let's plug it in and see if MATLAB likes it. So I'm getting 3 root 3 over 2. 3 root 3 over 2. Alright, it liked it. Now the last one, which is very uncommon in physics, because it doesn't occur naturally very often, it's asking us for the jerk at time pi sixth. So jerk is now just what we've gone through, but now it's how much acceleration is changing per unit time. So what that means is we're just going to take the derivative of acceleration with respect to time, which is the third derivative with respect to displacement. And that is going to equal the derivative of acceleration, which is 3 cosine t. That's going to give us negative 3 sine t, because the derivative of cosine is negative sine. We're evaluating it at time equals pi sixth. And that is going to equal, sine at pi sixth is 1/2. I think we did that already up here. So this is going to be 3 times 1/2, which is going to give us 3/2 again. Let's go ahead and try that out. Alright, it didn't like that. Let's see what I did wrong. Oh, I'm sorry, there's a negative in front here. So, and jerk is it's a vector quantity, so it's important that we put the direction, which is negative, in front of it. Alright, so it's happy there. And I think that's just about it for this problem. It is really cool to see how these physics concepts are related using calculus. And so I hope this was helpful, and I'll see you next video.